Okay, so this is grade 11 Precal, lesson 35, solving rational equations, part 1. So what we're going to do is now we're going to take all what we've learned about additions, subtraction, multiplication, division, reducing, and now we're going to solve for rationals. Okay, so what we got here is our big old rational. If you notice the differences, the other ones were expressions. This one's an equation because there's an equal sign. So the key to solving a rational equation is you're always trying to get the variable by itself. But to do that, to solve this, you have to get rid of everything that's in the denominator. So if you look, we got a big old denominator down, a whole bunch of stuff in the denominator down here. So first off, let's factor. So this is a perfect square. So z plus 2, z minus 2. 6z plus 12, there's a GCF of 6, pull that out. And this one is just z minus 2. Now, you got to look for your LCD. So if you look here, we have a z plus 2 and a z plus 2. We need a z plus 2 over here. So that's one of them in our LCD. We have a z minus 2 and a z minus 2. So we need a z minus 2 in the middle one. We have a 6 here, and we need a 6 in both those. So then we times it by 6. Okay. So there is our LCD. Z plus 2, z minus 2 times 6. Now you might as well, while you're here, figure out your NPV. So z cannot be equal to plus or minus 2. If you notice that, you can't plug in 2 into those because that makes that 0. Now, what we do is we space out the rational to give ourselves some room here, and we're going to multiply everything by the LCD. So we put it up the top left so it doesn't look like an exponent. Don't put it up the top right, put it up the top left. Top left, top left. And we multiply everything by that. Now, if you look, we can reduce a bunch of things. So z plus 2 and z plus 2, z minus 2 and z minus 2. So we're left with just 6 and 2 multiplied together down here. Here, we can get rid of the 6 and the z plus 2. So we're just left with a 10 times z minus 2. So then we're going to do distributive property. Here, we only can take out the z minus 2, so we're left with a 6 and a z plus 2. Now, since there's a 1 up the top, we just have to do 6 times z plus 2. Now, if you look, if you notice this whole line here, wow, this whole line is just a single line. There is no denominator. So you know you did it correctly because the denominator disappears. Okay, so then we go 6 times 2, 12. Distribute the 10 to both of these. We end up with 10z minus 20. And we times 6 by z plus 2, so we end up with 6z plus 12. Again, you have a nice bunch of terms here, rearrange them, get the z's by themselves. So you just move stuff around. Here you can combine the 12 and the 20. Then we can move the 6z over to this side and the 8 over to this side. So we end up with 4z equals 20 and z equals 5. Really quite simple. So the key here, and this is really, really important, the key here is when you times everything by the LCD, your next line should be just one single line, no denominators at all. That's different from when we did addition, subtraction, or multiplication or division. You might end up with that, but here you don't want to end up with that. So right there, everything is by itself. And then we have our z plus 5. Okay, flip the page, and we're going to do a pretty big example here. This one is going to take the entire page to do. So flip the page. Okay, so this example, if you look, quite complex. And there's lots and lots of pieces to it. So first off, let's look at the denominator. K plus 2, k minus 2. Oh, this one, there's a difference of squares. So factor that into two binomials. So we end up with k minus 2, k plus 2. Now, figure out your LCD. So if you look, we got a k plus 2 here, a k plus 2 here. We need one in that piece there. So k plus 2 is one of ours. We have a k minus 2, a k minus 2. So we need a k minus 2 over here. So that's the other part of the LCD. While you're doing this, you might as well figure out the NPVs. K cannot be equal to plus or minus 2. Okay, now that we know the LCD is k plus 2, k minus 2, space out your work. Give yourself some room here to work. Put your k plus 2, k minus 2 up the top, right there, and right there, right? Put them on the left-hand side. Don't put them on the right so it doesn't look like a exponent. Now, let's start reducing. So remember, the goal is to get rid of all the stuff in the denominator so you have one single line of work. So k plus 2, k plus 2 are gone. They reduce down to 1, so we're just left with 4k minus 1 times k minus 2. Yeah, we're going to have to FOIL that in a sec. Here, the k minus 2 and the k minus 2 disappear, but careful, there's a subtract there. So keep that out front. So it's going to be k plus 1 times k plus 2. This one, both the k minus 2 and the k plus 2 reduce down, so you're just left with this trinomial right here. Now, you know you did it correct, because look, do you have one single line of work? Yes, you do. Now we got to do some FOILing here, and we got to do some rearranging. Now, if you look, there's a k squared in here. So this is one of the ones we're going to try to set everything equal to 0 and then solve for it. Okay, so this one, we FOIL it. We end up with 4k squared minus 9k plus 2. This one, we FOIL it. We end up with k squared plus 3k plus 2. Now, if you notice, I kept that in brackets. There's a reason for that, because that negative at the front is going to change the signs in here. It would be like distributing -1 to all these terms. And the next part here, we just wrote it out again. So now this is the main line here. So if you look, we got rid of the brackets. So negative times k squared is negative k squared. Negative times positive 3k is negative 3k. And negative times positive 2 is negative 2. don't skip that. That's really important. And that's where a lot of students will make their mistakes. Now, we have a big old line here of work. Let's rearrange everything. We'll bring all the k squares over to the left-hand side. We'll bring all the k's over to the left-hand side. And we'll bring all the constants over to the left-hand side. So we do that. We end up with 2k squared minus 8k minus 24. Now, GCF right off the hop. Take out a 2. There's the 2 pulled out. So k squared minus 4k minus 12. Hey, factor this. This one factors quite nicely. We end up with k minus 6 and k plus 2. So then we split them because they're both equal to 0. We can solve this one. Now, the 2 doesn't make any difference in this case for when we're doing the work, remember, because 2 times any of these being 0 will still end up with a 0. So we're going to end up with k minus 6 equals 0. So one of the answers is k equals 6. The other one is k plus 2 equals 0. We end up with k equals negative 2. Whoa, whoa, whoa. Wait. What did we say that k cannot be? Way up the top here, we said, oh, look, k cannot be equal to plus or minus 2. And we ended up with that in one of as our answers. Oh, we can't do that. So k cannot equal negative 2. So therefore, we know this before, that negative 2 is an extraneous root. We needed the negative 2 to be able to do all the math for this question, but it's not one of the answers when we finally get to the end. Okay, so key things here. Make sure you get your LCD correct, right? Always double check that. Slow down, go back and make sure that that's correct before you do any of the work. You're going to multiply everything by the LCD, and hopefully, if you've done it correctly, your next line is just one single line by itself. All the denominators have disappeared. And then just work through like you normally would to solve for it. And be careful of extraneous roots. Okay, so that was lesson 35.